Chapter 5b, Day 4. Learning target. I'll be able to solve quadratic inequality solutions algebraically. And I gave you the information of the steps that you need to solve the quadratic equations, quadratic inequalities. So follow along the steps. Express the inequality as ax squared plus bx plus c with a greater than 0. So make sure your a is greater than 0. If it does not equal to 0, what do? You can multiply everything by negative to make it greater than 0. Okay? Second step, find the roots of ax squared plus bx plus c equals 0 and sketch the graph of y equals ax squared plus bx plus c. So this is basically using the method we discussed in 5a. You can either use the factoring fish method, you can use the common factors, you can use the quadratic formulas, you can use the completing squares. So basically, you are going to find the roots, find the x values that will make the equation, the quadratic equation is equal to 0. Read the answer from the graph as the third step. So let's practice these 3 quick examples. X squared minus 3x greater than 0. So is it already in the form of ax squared plus bx plus c equals 0 with leading coefficient with your a greater than 0. So since a is 1, so that is. So the next step, what do I do to find the x values? So I can use the factor method. So I factor out x from each term. So I have x times x minus 3. So I know my roots, my x-intercept is going to be 0 and 3. So what are my answers? So it's going to be x greater than 3, so on this side, or x less than 0. How about the second one? X squared minus 6x plus 5 less than 0. So what are the x-intercept? If you use the factoring fish method, you're going to find the zeros are going to be 1 and 5. And since we're looking for less than, your x value is going to be in between 1 and 5. So x is less than 5 and greater than 1. You can test it by, so pick a point here. Say like 2. Would it satisfy the equations? Plug it in to test it. How about pick another point here to test it? 6. Will 6 pass the test? Obviously it won't. How about something like 0? If you plug it in 0, will it satisfy the equation? No, it won't. So the only solution is going to be in between 1 and 5. And using the inequality form, this is going to be our answer. X less than 5 and greater than 1. The third one, the next one, negative x squared plus 6x plus 7 greater than 0. So remember, we have to change that into positive a. So I multiply everything by negative. So I change everything by negative. Multiply everything by negative. So I have x squared minus 6x minus 7 less than 0. Use the factoring fish method to find the x-intercept. X-intercept is negative 1 and 7. So since it's less than 0, again, it's going to be in between negative 1 and 7. Your x value is going to be in between negative 1 and 7. So now let's take a look at some examples. Number 1, equation. Solve x minus x squared greater than 0. So here I would like to remind you, you can write this as negative x squared plus x greater than 0. We have to keep our leading coefficient as positive. So I'm going to multiply everything by negative 1. So that makes the equation x squared minus x less than 0. As you multiply negative, make sure you switch the sign. If it was originally greater than, then it becomes less than when you multiply the negative sign. So what are the x-intercept? So obviously I can use the factoring fish as we did with the very first example. X times x, I have x squared. X times negative 1, that's negative x. So what are the x-intercept? So obviously this is going to be 0 and then this one is going to be positive 1. So what's going to be our solution? Since it's less than, it's going to be in between 0 and 1. So x less than 1 and greater than 0. Example number 2. So this time, I'm just going to add 6 to both sides. So x squared plus 8x minus 2 less or equal than 0. Using your factor fish method, I have x plus 2 times x minus 1 less or equal than 0. Mark down your x-intercept. Your x-intercept is going to be positive 1 and negative 2. And since it's less or equal than, so your value is going to be, x is going to be in between 1 and negative 2. Again, how do I figure out these numbers? Pick a point to test it. So what's a good number in between 1 and negative 2? I would assume you would pick 0. Go ahead and test 0. Is 0 squared plus 0 minus 8 less than or equal than negative 6? Is this true or false? So negative 8 is indeed less than negative 6. So I know the solution is going to be correct. Equation number 3. X squared plus 10x plus 25 greater than 9. So I'll subtract 9 to both sides as my first step. I have x squared plus 10x plus 16 greater than 0. Use the factoring fish method. I have x plus 8 times x plus 2 greater than 0. So since this is greater than, then your solution is going to be outside your x-intercept. Our x-intercept are negative 2, negative 8. So outside of these regions, it is going to be x greater than negative 2 and x less than negative 8. Equation number 4. So this is a little bit tricky again. I'm going to rewrite it as negative x squared plus x less than 12. Then I'm going to subtract 12 to both sides. I have negative x squared plus x minus 12 less than 0. I like to keep my leading coefficient a positive, so I'm going to multiply everything by negative 1. Make sure if you multiply by negative, you have to flip the sign. So we arrive at x squared minus x plus 12 greater than 0. From here, we do a factoring. Factors are x minus 4 times x plus 3. And again, it's greater than, so it's going to be outside of your x-intercept. Our x-intercept are 4 and negative 3. So the solution is going to be x greater than 4, x less than negative 3. So again, pick points to test your result. Equation number 5, I have x squared plus 2x, and I'm going to subtract 14 to both sides. So I have x squared plus 2x minus 24 greater or equal than 0. The factor, again, use your factor fish. It's going to be x plus 6 times x minus 2 greater or equal than. So your solution is going to be outside of your x-intercept. X greater than 2 and x less than negative 6. Again, pick a point to test it. Make sure you pick your points to test your result. There's no better way for you to check on your inequalities by using testing points. And what are the points you can choose? As long as it satisfies your equation solutions, x greater or equal than, x greater or equal than, x less or equal than, then your solution should satisfy the equations.